trying to find a global max min. Here I have completely open-ended interval, so we'll have to check limit behavior on both ends. So the limit as x approaches negative infinity of our function k, and the limit as x approaches infinity of our function k. We don't have any discontinuities this time. Exponential functions are defined everywhere, so even if you do a little bit of weird stuff in there, unless you have a domain problem on that numerator or that exponent on its own, you should be fine. So we're just going to look for critical values. So the derivative of k, let's see, the 4 goes away. The derivative of e to stuff is e to stuff, and this negative out in front is just a constant multiple that'll come along for the ride. And then we've taken the derivative of e to stuff, but we haven't taken the derivative of the inner function. So we're going to have a power rule. The negative just comes for a ride again, different one. The 2 drops down in front. You get x minus 2 to the first, and then there's actually one more chain, the derivative of x minus 2, but that's just 1, so it ends up being an easy one. And we want to set this equal to 0. Once again, it's never undefined. We've got an exponential and a linear piece, and both of those work fine. I can see that some negative signs are going to cancel out. I'm going to reorder just a little because I like it. Okay, so there's my function. The exponential, the e to a power stuff, is never going to equal 0, so we actually don't get any information there, but this one will, if x equals 2. So this is our critical value, and we will need to check k of 2. And k of 2 is 4 minus e to the 0. E to the 0 is 1, so 4 minus 1 is 3. And now we need to do that limit thinking, and this is actually really important calculus thinking. So if I'm looking at 4 minus e to the negative x minus 2 squared, and x is going to negative infinity, okay, so the negative infinity, so huge, huge negative number, but then I square it, it becomes an even bigger positive number, but then I multiply it by negative 1, and I have a monster big negative power. When you raise e to negative powers, that's the same thing as saying I have 1 over e to the x minus 2 squared. When you raise e to big negative powers, it's like 1 over e to big positive powers. So this is a huge positive number, and it's in the denominator, so this fraction is going to go to 0. We're going to get a tiny, it will be positive, but tiny number. And when we subtract that from 4, we're going to be really, really close to 4. So as x goes to negative infinity, y goes to 4. And as x goes to positive infinity, you actually end up with the exact same argument because of the square. So whether this is negative a million squared or positive a million squared, we're still going to end up with a negative exponent because of that minus sign. So this is 4 as well, which means I do have a global min, but I don't have a global max. It's tempting to say it's 4, but you have to recognize that this is a limit, so it's kind of like the open circle thing. So what's happening here is here's y equals 4, and we go through what point? 2, 3? Yeah, 2, 3, and it's just doing, let's see, it's pretty subtle. It's just dipping down and then heading right back up again. It's kind of what we're getting. So you can see that we do approach the x equals 4, but we don't actually hit it. And you can tell that algebraically. You don't have to just believe my picture. If we take this 4 minus e to the negative x minus 2 squared and set it equal to 4, we can subtract the 4's off, and we get negative e to the negative x minus 2 squared equals 0. And exponential functions never give you 0. They have limit behavior. They get close to 0, but they never actually hit it. So no global min. Okay, so that hopefully gave you a decent idea of some of the funny things you can come up with. So watch for discontinuities, open endpoints, open-ended intervals. Use limits to check out any of those. And then you want to also be checking out your critical values and your endpoints, any closed endpoints. Those you can just plug straight into